Okay, we're recording again. Share screen, sketchbook. Okay, so we're going to do some example problems here because example problems are fun. Y equals 2e to the square root of x. So for the derivative, well, of course, we're going to rewrite this 2e to the x to the 1/2 power, right? We don't want to mess with square root signs. Now the derivative. So this is 2 times e to the u. So the derivative is going to be 2 times e to the u, x to the 1/2 times the derivative of the exponent. Derivative of x to the 1/2 would be 1/2 x to the minus 1/2, right? So this would be one-half x to the minus 1/2. And these two will cancel, the 1/2 and the 2, and we'll end up with x to the minus 1/2 e to the x to the 1/2. Oops. Yeah, that's right. And if we wanted, we could change this to square root again. We could move this into the denominator if we really wanted to, because it would make us cool. E to the square root of x over square root of x, right? When this goes into the denominator, you change the sign on the exponent, and we can put it back to square roots. Makes us look smart. Okay. Any questions? No questions? Oh, great. Okay. Cut. It's got to go away. And where are you right there? How do I move you? I don't know how to do that. Okay, I'll leave it alone. Okay, go away. There we go. Okay, here is problem we're going to solve two ways. And we're going to do it two different times. 1 plus e to the 5x over e to the 3x. We can't cancel anything here because there's no e to the 5x or 3x over here, right? So we can't do any canceling. We can only do that if we can factor an e to the x out of both terms in the numerator, which we can't do. Let's see if I know, forget it. So I was going to try to erase this, but I don't really know how to erase, so I'm not going to mess with it. So now the derivative, we can do the quotient rule, and if we do the quotient rule, here's high and here's ho. And if we remember the quotient rule, it's ho d high minus high d ho over ho squared. The ho always goes first. Poor ho. So this will be ho d high, so e to the 3x. D high, the derivative of 1 will be 0. Derivative of e to the u is going to be e to the u times du. Ho d high minus high, 1 plus e to the 5x. D ho, so the derivative of the bottom, e to the 3x times 3, all over ho squared, e to the 3x squared. And we need to do some simplification there, right? Okay, now if we, let me get rid of this. Cut, go away, go away. Now if I rewrite this instead as 1 plus e to the 5x times e to the minus 3x. Now I can do the product rule. Y equals, so derivative of the first, Derivative of a 1 is 0, so we need the derivative of that. So that'd be e to the 5x times 5. Times the second, e to the minus 3x. Plus the first, 1 plus e to the 5x times the derivative of the second, e to the minus 3x times a negative 3. That'll be our derivative if we use the product rule. Okay, happy with that? Now let's switch it around. Let's do the reciprocal of it. Y equals e to the 3x over 1 plus e to the 5x. I want the derivative of this. Now we could write it e to the 3x times, 1 plus e to the 5x all to the negative 1 power. We could do that. That might make it easy, might make it ugly. I don't know which. We'll do it both ways because that makes it more fun to do it both ways. So the quotient rule, so I got high over ho. So ho-de high minus high-de ho over ho squared. Ho d high, so e to the 3x times 3 minus high d ho, so the derivative of 1 will be 0. Derivative of e to the 5x is e to the 5x times 5 all over ho squared. 1 plus e to the 5x squared. I hope no one asked me to simplify this beast. We could probably do it, but it's not going to be very pretty. Now let's do the product rule. So we'll do the derivative of the first. So e to the 3x times 3. Oops, sorry about cutting you off at the head. Times the second, 1 plus e to the 5x to the negative 1 power. Plus, now we do the first and we take the derivative of the second. So e to the 3x times the derivative of the second. Now we got to use the power rule because we have a function raised to a power. Minus 1 times the function to n minus 1 times the derivative of the goop inside. And the derivative of the goop inside here, u prime, derivative of 1 is 0. Derivative of e to the 5x is e to the 5x times a 5. And there it is. And you can see the similarities between these solutions. You see here you have a 1 plus e to the 5x squared in the denominator. And here's a 1 e to the 5x to the negative 2. So that's going to put it in the denominator down here, but you got to work to get it down here so we can combine them. They are the same. I'm convinced I could make them prove that they're the same, but I really don't want to, so I'm not going to. So we're going to stop this here. We'll pick up another couple of types of problems in the next video. Thanks.